All right. Welcome, everyone. Thank you so much for coming to the Continued Expertise on Demand Lunch and Learn series. This month, we are continuing with the theme of last month's session, just helping you search more effectively, write faster searches, and be more organized as you create content in Splunk. Joining me today is Brett Woodruff, Systems Engineer on the Expertise on Demand team. My name is Ellis Devaney. I will be in the background today. You can always reach out to either of us, to the Expertise on Demand team, and we're happy to help you with any questions you have about the topics discussed here. So we will be talking this month about Splunk data models. And Brett, you can take it away.
All right, thank you, Ellis. As Ellis had said, my name is Brett Woodruff. I'm a systems engineer on the CX team, and I'm a certified Splunk architect. I've been with KGI for about 2 years and been working in the IT industry for about 17. And today we're going to talk about the basics of data models and how to use them. So let's go ahead and move on with the show. The agenda for today is we're going to go over data model overview, Splunk Common Information Model add-on, normalizing data, data model acceleration, and searching data models. So why would we want to use data models? It simplifies searching by enabling a common set of fields and tags to search multiple data sets. It can increase search performance through data model acceleration, fast adoption using the Common Information Model or Splunk SIM. It allows for simple correlation across multiple log sources. Splunk data models allow for simple and efficient SPL searches that can be used to search across multiple vendor data sets. This makes search and dashboard queries simpler, easier to read, and automatically include new onboarded data sets. Here we have the basic operation of how a data model works. Once the data set, Nginx and Apache in this diagram, have been normalized, we can search against the data model and its fields to return the data from all associated data sets. So searching the web data model using the field name SRC will return results from both Nginx and Apache and their field names associated with SRC. So we effectively search both data sets with a common field and no unique index references. Normalization aligns fields of unique data sources to the Common Information Model standard names. It uses common, consistent fields that apply to multiple data sets mapped to the data model, generally achieved through aliasing, which is creating a new field with an expected name, and the value is tied to the value of the original field, and also through evals, which create or overwrite the SIM field to match a set of expected values. A simple example of this would be using something like a soft. This would typically be called something like pop or soda. But no matter where you're from, you know that soft drink is synonymous with both dialects. The same thing happens with data models. It creates a synonymous link between the SIM compliant field and each associated dataset or vendor's default field name. So where do I start? Well, there is the Splunk Common Information Model or Splunk SIM. It's a free add-on. It's ready to use right out of the box. It provides data models for commonly ingested data types, commonly used and required by many app developers, and heavily used with Splunk premium apps such as Enterprise Security. It can be downloaded and installed from Splunk Base, or you can use the link that's provided on this slide. Some technical add-ons or TAs may be SIM compliant right out of the box, while others may not. Today we have 2 tutorial data sets. One is SIM compliant and the other one is not. We're going to walk through the process of making the second data set SIM compliant. Some may ask, why not use multiple index references and commands to rename similar fields in a query? Well, as more unexpected data sets are onboarded, every search previously created will need to be edited to include the new data sets. This would include scheduled searches, saved searches, and dashboard queries. It also creates overly complicated queries that become increasingly harder to read and understand as the number of data sets and fields grow. Some data sets can be extremely large, and not taking advantage of data model accelerations can make waiting for the results very long. So if we switch screens here, you should be able to see a Splunk environment here. If we go and click here, we can see we have an index with data in it. This is our SIM compliant data, but right now we're looking at it just simply through the index. Same thing here. We're looking at the web index, and this is going to be our tutorial non-SIM compliant data. Now, if we go and look here, this is searching the web data model. And if we turn around and we look at the source types that are included in that, we can see that the access combined source type is included in the web data model. Now, if we go back and we look at our Apache index and we find our source type, we can see this data is included, whereas the source type for this one, access combined with cookie, is not currently included in this web data model. So to get that second data set incorporated into the data model, first thing that we're going to need to do is go to Settings, Advanced Search, Search Macro, and we're going to change the app constraint to all. We're going to search for the SIM web macro. And what this does is it affiliates the indexes that we want to attempt to include in the data model. So we'll edit this to include our second index. And then click Save. So the next step that we want to do is we want to create an event type. The event type applies tags to the data that is being indexed, which is what the data model references. So what we're going to do is we're going to go up here to Settings, Event Types, create a new event type. First thing we're going to do is associate it with an app. If you don't have an app that you want to associate this specific event type with, you can leave it as search. And we're going to give it a name. Our search string. And our tags. What we're going to be tagging this with is proxy and web. The web tag imports it into the web data model, and the proxy tag imports it into the child subset data model of proxy, because we're going to import this into the proxy child data model. We click Save. And the last thing that we need to do is create field aliases to correct any fields that don't align with our data models fields. So what we want to do is go to Settings, Fields, Field Aliases, and we're going to create a new field alias. Same thing applies here. We can associate this with an app, otherwise you can leave it with search. And we're going to give it a name also. And our source type is the source type that we seen for that data when we originally searched it. So that was access combined with cookie. Here we need to list what our fields are that we want to grab and what we want to alias them to. So if we go back, we can actually see the list of fields that are provided in the index data. And if we turn around and let's see, go up here into data models, and we look for the web data model, we can see a list that the data model expects as far as fields. So what we would want to do is correlate the indexed field names, which would be something like this. So in the index data, it's client IP, and we're going to create an alias of source that refers back to this. We're going to create several of these. Getting ahead of myself. Okay, now that we've got these all listed out, we can just click Save. Now if we go back to our original data model search, and as we can see, it's only got one source type listed. And we refresh this, we should get two. Now we're also including the data from the second data source in this. So now that we've got our data included, let's switch back to presentation. Let's talk about data model acceleration now. Data model acceleration and fast search results. Splunk data models can also be accelerated, much like an accelerated report, but by using summaries of the data. Search performance increases when coupled with T-stat searches, but outcomes do come at a cost of additional storage requirements. So what's the difference between an accelerated report and data model acceleration? Well, accelerated reports build from search results, where data models build across tagged data sets to provide quick access to SIM fields. This will result in dynamic results that can be flexible with the data model configuration. So let's accelerate our data model now. So if we go back here to our data models, we can see this column right here of these lightning bolts. The fact that they're grayed out means that they're not accelerated. So if we want to accelerate the data model that we're working with today, which is the web data model, all we need to do is click on Edit, Edit Acceleration, and check the checkbox for Accelerate. It's then going to ask us about a summary range. The summary range is how far back do we want to create the summary. Now, depending on the amount of data that you have and your total amount of data sets and the amount of summary range that you provision will ultimately determine how much additional storage will be required. For this demonstration, we're just going to leave it at 7 days. Now you can see that this is lit up and yellow. If we go over here and we click on this caret, we get specific information about the current status of the data model and acceleration. Depending on the amount of data that you have being funneled into the data model, the number of data sets and the amount of data in those data sets, this may take a while. I don't believe I've seen one take longer than 30 minutes, but just be prepared that when you do accelerate these, the data may not be immediately available until this has reached 100%. Since we're using tutorial data, it's fairly small, so it's extremely quick. So let's go back to the presentation. All right, now that we've made our second data set SIM compliant and waited for the acceleration to build, we can now perform data model searches. And it should include our new data set and result, which we've already shown that. So let's do a couple of searches to see what we can do with it. So I've got a couple of canned searches here that we can run against this. So once again, we're searching the web data model and we're returning the top 5 user agents. Now, if we click on the events tab, we can once again see that we are searching both sets of data with this single query. Another basic but kind of cool search that we can run against the data model. Would be this, which basically gives us a visualization of where all the source IP locations are that are in our tutorial data. Now, some of these ain't going to make sense. They're out in the middle of the ocean because it's just randomized tutorial data. But this would be the equivalent of like a dashboard visualization. So we can use these same queries, these data model queries, even in dashboards. Now, the next thing that I want to show you is a simple search. What we're doing here is we're searching at the web data model again for the child data set of proxy. And we're pulling the status codes out and displaying the count of them. Now, as you can see, if we go back here and we grab another search that does not use our web data model, we get the exact same results. Because with this one, we're only searching the second set of data because we included the proxy child set, which is only this data. And we're getting the exact same results. The difference here is the fact that this is also accelerated. So if we go back and we look at the job and inspect it, we can see that this query took roughly around 1.3 seconds to complete. Whereas if we look at the accelerated search, we can see that this actually took less time. Now, with much larger data sets, this will get more and more pronounced, exponentially more pronounced, actually. The reason why it's so small of a gap right now is because our data set is extremely small. So, and with that, we want to make sure that you If you haven't checked out last month's webinar, which ties in directly with with TSTAT searches, which utilizes accelerated data models and accelerated searching, there's a link provided there, and I believe Ellis is going to be putting that link in chat.
That's correct. Yep.
Okay.
And clipboard issue. But just a reminder to everyone that we are always happy to discuss these topics. We had some great information following the last session, customers interested in discussing how they can implement TSTAT searches. So we are really hoping that this was helpful to you, a good introduction to the concept of data normalization, leveraging data models, and we hope that we can do some meaningful work with you all on this topic. So with that, I definitely want to keep everything open for questions. We'll be looking at the chat for a few minutes here, but thank you everyone for your attendance. If you do have questions, the easiest way to reach out to us is the support@Kinney Group email address. So you can see that on the screen now, support@kinneygroup.com, and someone from the team will be in touch with you. All right, not seeing any questions right now. I'll stick around for just a few minutes, but thank you, everyone.